Hello students, following question is from part test 1, subject digital logic, chapter sequential circuit. And the question is asked for 2 marks. In the question we are given a circuit and we are required to find whether this circuit represents a mod 2 counter, mod 3 counter, mod 4 counter or none of this. Fine. So first of all let us study what is mod n counter. So mod n counter is nothing but it has n different states, that is, each state repeats itself after every n states, or I would say n clock pulse. Fine. So for this given circuit we would find the solution in 2 steps. And my first step would be finding my inputs to the flip-flop. If you look in the circuit, you would get TA is equal to QA plus QB. It is QA plus QB. And my input to that second flip-flop, that is over here, is from QB or with, it is actually like this. Fine. QB plus QA bar. So what I get is my input as QA plus QB for TA, and TB is equal to QA bar plus QB. In the second step we would construct a table, so to find our output. So first column would be a clock pulse, second would be present state, next inputs and the next state. Since we are given T flip-flop, so we must know the truth table of T flip-flop. So for truth table of T flip-flop states that T is my input and Qn plus 1 is my next state output and Qn is my present state output. So if T is equal to 0, so my next output would be same as my previous output, that is no change in my output. However, if T is equal to 1, then my output toggles. So if initially it was Qn, so now it would be Qn bar. Fine. So using this truth table and we will fill this table, initially we will assume our present state to be 0 0. So I would, using this relation over here, that is from step 1, I would get entries over here as 0 1, and using this truth table I would find this entry as again 0 1. Since it is 0, so previous output continues. Since it is 1, so output toggles. So from 0 it goes to 1. Now this next state output acts as my present state output. So it would be 0 1. So again using this relation I would get my input as 1 1. So again both of my output will toggle. So what I will get is, instead of 0 now I will get 1 0. Now using again this relation I would get my next entry as 1 0. So again my first output will toggle, so from 1 it will go to 0, and since over here I have 0, so 0 will continue. So if I look carefully, so my output after third clock pulse is same as my initial output. So I can say that we have 3 different states. That is, my counter is mod 3 counter. So your output goes from 0 0 to 0 1, from 0 1 to 1 0 and back to 0 0. So whenever we are given such kind of question, what we will do is solve the question in 2 steps. In first step we will find the inputs to the flip-flop, and in second step we will construct the table. So hence what we get, our final option as option B, that is mod 3 counter. Thank you.